Hi girls, I'm just going to do one more moles question for you, and this one is from 2019. It's the year just gone by, the last exam that you had, the most recent leaving cert is what I'm trying to say. 2019, question 10, part C. Okay, so this is 2019, question 10, part C. And we're doing this one because it's very similar to quite a few that have come up recently where you're not just dealing with one equation, you're kind of dealing with a few. So we're going to work through it and see what we're being asked. The very first part of this question, again, you might want to dig it out and read along while I'm doing it. It says when 3.17 grams of mercury thiocyanate is heated, it decomposes according to the equation that I've written down there. And the first question is, what mass of C3N4 is produced in this reaction? So the first thing that I've done is I've written out the equation. I've written the information underneath the part that's relevant. And I've written down what I'm looking for, which is the mass here, okay? So the first thing that we're going to do is, because we've been given the mass of the reagent, we're going to work out how many moles that is. So the first thing that we're going to do is we're going to go to our periodic table, and we're going to work out what 1 mole of HgSCN2 is, okay? We're going to tot all that up. Mercury is 201, sulfur is 32, carbon is 12, nitrogen is 14, tot all that up, you get 317 grams. So we're going to divide what we have, which is 3.17, by 317, like this. And we're going to get 0.01 moles of reactant to start with. Okay, so we started with 0.01 moles of this, and the question is, what mass of this did we get? So first of all, we have to work out how many moles of that we got. So we're going to use our molar ratio to help us do that. And in this case, as you can see, from the equation that we're given, the molar ratio is 2 to 1. So if we started with 0.01 moles, we're going to divide that by 2. You see that there? Sorry, I'm getting my angles all wrong this morning. Is 0.005 moles of C3N4. Like that. So that's the amount of moles of C3N4 I got. I now need to turn that into mass. How do I do that? I go back to my periodic table. I work out what 1 mole of C3N4 is. And that's equal to 92 grams. So all I have to do is multiply 0.005 by 92, and I get 0.46 grams of C3N4 produced. Okay, so that's the first part of that, and that's relatively straightforward. You know, if you were able to do the couple of the other simpler examples that we've looked at so far, you should really be able to work out that bit. Shouldn't be an issue for you. I suppose things get a little bit more complicated maybe later on when we're asked about some of the other aspects of this equation. So we're going to just look at that now. We're going to look at part B. And part B tells us that if all the reactions go to completion, the question is, how many litres of oxygen gas measured at STP are required for the complete combustion of the CS2? So we're just going to look at what we're given in the equation first, right? I'm not going to read all these out. I've written them down so you can see, okay? So that top equation there that you can see here, I'm going to point to it now if I can. This one here is what we just started with. So we just worked out that we had 0.01 moles of this at the start, which means we're going to produce 0.01 moles of mercury sulfide, 0.005 moles of CS2, and 0.005 moles of C3N4. And we're then told that 3 further reactions happen with each of these products as they decompose. So we're going to use these equations now to work out, first of all, how many litres of oxygen gas measured at STP are required for the complete combustion of CS2. So we're using this second equation here, and we're working out how many moles of oxygen are needed to burn all of that. So the first question is, how much of this was actually produced? Well, we've worked that out already from our molar ratio here, because we know that we started with 0.01 moles of mercury SCN2, and we know that the molar ratio here is 2 to 1. So basically, we're going to start with, over here, half the amount of CS2, isn't that right? Which is 0.005 moles. Does that make sense? So what we're doing is, we started with 0.005 moles of CS2 here, okay? And the amount of oxygen that we're going to need is 3 times that amount. All right, so we're going to multiply 0.005 moles times 3, like this. And we're going to get 0.015 moles of oxygen is required. Now we're asked to work out the volume in litres. So we know that 1 mole of oxygen, because it's a gas at STP, has a volume of 22.4. So we're going to multiply 22.4 by 0.015 like that. And what we're going to get is 22.4 multiplied by 0.015, and we get 0.336 litres, like that. Okay, I'm going to complete this question on another video because it's getting a bit long. So I'm going to shut up now and do a second part of this.